Hello, everyone, and thank you for joining us today. With me, as Alina said, is also Christian from Tiva. But I will give you a short introduction to Tiva, what we do and what we can offer. I have tried to keep this presentation relatively short. I can spend a whole day talking about this, but to make room for questions, I decided to keep it kind of short. And you have the ability to ask any questions at the end of it. So as Alina said, she explained a little bit about my background, but I wanted to cover that in a little bit more detail to explain where we are coming from. My own career began as a computer programmer, but after the big IT crash we had, I decided to take an opportunity to do something else and follow a lifelong passion. I always had a huge interest in fishing and nature, so I began studying to become a biologist. After my exam, I started working for a university in Sweden, conducting field studies on fish migration patterns, mainly using radio telemetry and pit tag systems. And after that, in 2010, I moved on to a company in Sweden specializing in designing fishway solutions at hydropower plants. And this company also sold and installed fish counters from another supplier. But with my technical background, I quickly became deeply involved with this system and started developing our own web-based software to be able to download, monitor operations, and analyze data from these fish counters. At the time, we had more than 50 fish counters in operation in Sweden at the moment. So in 2018, as artificial intelligence and image recognition started becoming more common, an idea was born. And the idea was essentially, are we able to create a fish counter that only uses cameras and AI to identify fish, count fish, and also automatically do species detection, and integrate the web-based system we have already built to monitor operations and download data? And were we able to do this at a lower cost than the current systems on the market? So we started working on it, and we had our first prototype deployed in early 2019. And it worked really good. So in 2020, we founded Tiva to streamline the business and focus entirely on fish counters and environmental monitoring in water. So every feature that is in the Tiva system is essentially a direct response from a real-world frustration I have personally experienced working with fish counters. And the AI that is in the system, it's been there from the start. So we don't really speak a lot about AI and fish counting when we market ourselves, but it's a really crucial part. It's not a gimmick. It's the solution that we don't have to put in all manual work for reviewing thousands or hundreds of thousands of false registration of leaves and bubbles and manually identify fish species. This background makes us not only a supplier, but also a partner who understands real-world challenges. Our experience has taught us that there is really no one-size-fits-all solution for fish monitoring. Different questions, different environments and budgets requires different tools. Therefore, we offer an ecosystem of products designed to meet these varying needs. And today I wanted to talk about 3 of our core products that we offer. The Tiva FC, that is our high precision fish counter, the Tiva UVC, our flexible underwater camera, and the Tiva Edge, that is our newest device that makes existing infrastructure intelligent. Think of this slide as an overview that highlights the primary role of each product, since they have different use cases. But all of these products are standalone edge devices with real-time on-device processing. Each of these connects to our Tiva Cloud platform, containing all the necessary tools to handle all the data. Let's dive into the specifics, starting with the Tiva FC. This is our flagship product, developed for a situation where every fish counts and accuracy is paramount. The system is based on a tunnel design that guides the fish past an advanced sensor package inside an air-filled camera cone. The system uses a dual camera setup. The first one is a high-resolution network camera with a large image sensor, crucial for delivering sharp and clear images even in difficult lighting conditions and if fish moves really fast. The second is a 3D camera that enables precise size measurement of each passing fish. The fish detection is performed on the device using advanced image recognition and tracking algorithms. Our software analyzes the video stream in real time and tracks the movement of each individual fish through the tunnel. The system can handle multiple fish in the tunnel simultaneously and count them individually. Inside the tunnel, there are 2 LED ramps or lightning bars, each equipped with a combination of white and red light. This is very important, not disturbing or scaring nocturnal species like eel, char, barbel, or burbot during the night migration. This light system is powerful with very strong lights and is fully customizable. If you, for instance, have high turbidity with large particles in the water, you have to decrease the strength of the light to increase the visible range. If you use strong lights in situations like that with high turbidity, the large particles will reflect most of the light back to the camera, similar to using the headlights on your car in a snowstorm. The default setting of the system is switching between the day and night mode, as we call them, at sunset and sunrise, but you can control everything manually as well. So this is a topic we can spend a lot of time on, but I won't go into too much detail on this topic during this presentation. But with a fish counting system, you have to guide the fish through the tunnel, and there are several key considerations for this. But essentially, we have to create a guiding device for the fish. A typical use case is to place the fish counter at the upstream's end of a fish pass. That is like the most normal placement of a fish counter. And if this can be taken into consideration early in the design phase of a new fish pass, that is a big plus. The pictures you see on the screen, the location here shows a permanent year-round installation of a fish counter in a nature-like fish pass in Sweden. It's been in operation for 4 years continuously now, I think. The fish counter is placed inside a cage with grills. And there's actually 2 cages here. You can see a smaller cage to the right and the cage to the left with the fish counter. But they are placed in a deeper and wider section than the fish pass itself. And of course, there will be leaves, branches, and floating debris getting stuck on the structure. But designing it like this with a large surface area makes it less prone to completely cover up and affect the hydraulics of the fish pass. It is also essential to design the structure in such a way that persons responsible for maintenance easily and safely can lift up the fish counter and clean the equipment when needed. This particular installation is cleaned every week during the summer and autumn, every other week during spring, and once a month during the winter. I want to stress this once again, how important it is to carefully think about the placement and installation. It's important for the fish, the hydraulics, but also for the persons responsible for cleaning the equipment. And we have been involved in installing a lot of fish counters in fish passes, and we are more than happy to help with input regarding the placement and guiding devices, since it's such a big key consideration. I also wanted to show you some other examples of other installation types and guiding devices for the fish counters. In Sweden, we have moved from not only just placing fish counters in fish passes, we are placing a lot of fish counters in open river installations as well. Excuse me. So on the left picture, you can see a fish counter placed in the middle of a river using in-river materials such as stones to guide the fish. And this is more like a behavioral barrier. This system has to withstand periods of high flows when there's a lot of rain coming. And in those situations, fish may pass over the stones and not pass through the fish counter. But this is a calculated trade-off to be able to cope with high flow situations. On the right side is another open river installation with the fish counter placed in a tower. Here it's possible to go out into the river and lift the fish counter up to be able to clean it. For guiding the fish, we are using resistant board weirs. It's a invention from Canada, and it's used a lot in Scandinavia. These resistant board weirs are attached to the bottom of the river and essentially adjust to the water level above. An installation like this is quite resilient to different water levels and provides good guidance for the fish, and is also easy to clean and maintain. If there are a lot of debris that get stuck on the weirs, they essentially just drop down below the water surface and clean themselves. And if there are large debris like trees or canoes or boat coming through the river, they can just pass over the barrier because the bars will sink down in the water. As I mentioned, our system uses visual algorithms, detection algorithms, to track and count the fish. I wanted to show you some examples related to the most common questions we get. The first one is how it performs in turbide water. Many of the rivers in Sweden are humic and have high turbidity. So we specifically trained our models on a lot of images from these conditions. The result is that the fish detection is surprisingly accurate, even when visibility is very limited. The algorithm is also trained on not detecting non-fish objects like bubbles from turbulence and leaves going through the tunnel. The second most common question we get is how small fish we can count. The limit is not the actual size of the fish, but how well the algorithm can detect the fish. In the software, you can set both the size limit, but you can also set the detection confidence, how sure the model is that it is a fish. Let me start the video. So in Sweden, we have multiple installations with fish counters, where the main purpose is to count downstream migrating smolts, sea trout and salmon smolts, between 10 to 15 centimeters in length. The accuracy is, of course, dependent on the confidence threshold that it is a fish, combined with the turbidity in the water. You can have situations where a long leaf from a tree, for example, like a willow tree, that can look a lot like a small silvery fish, especially during nighttime with red or infrared light. So if you set the confidence level to a low value as well as a small fish length, you will get some false positives from the system. But I will get back to the limitations of the system later in the presentation. And let's move on to the next edge device, the TIVA UVC, or the underwater camera. This system is designed for flexibility and fast deployment. We are careful to always emphasize the distinctions from the fish counter. This is fish monitoring, not exact fish counting. There will always be situations where fish swim too far away, outside the camera's field of view, or in water too turbid to be accurately counted. Rather, you should consider this product that it is for observing fish behavior and migration pattern at a larger scale. The system uses the same high-quality camera as we use in the fish counter. Of course, it's placed in a waterproof housing, and this waterproof housing also has a convex lens, providing a 120-degree wide-angle view. So it's really wide-angle camera. But the camera also has a 3x optical zoom. So if you have clear water and you need to zoom in a certain region of interest, you can do that as well. The computer responsible for analyzing the camera is placed inside a control cabinet that is placed on the riverbank or on land. But it uses the same technology with real-time detection of fish, minimizing false detection. This system's strength lies in its adaptability and easy installation. It's designed for rapid deployment without the need for fixed permanent structures or guiding devices. Mounting options are really flexible. You just attach it to some sort of structure of any kind. And we also provide a riverbed mount, the large picture you see to the right. That is made of stainless steel and weighs about 20 kilograms. So this makes it really easy just to carry out the camera and the riverbed mount wherever in the river or in the water where you expect fish to move. Also, the system is scalable. You are essentially able to connect up to 4 cameras to one of these compute units and still perform the fish detection in real time with 25 frames per second for each camera. This enables monitoring of wider rivers by placing multiple cameras in series, like the picture below. Or you can evaluate the efficiency and delay at the fish pass by placing one camera at the downstream end of the fish pass and one at the upstream end. Using real-time AI detection of fish in open water environments can be quite challenging. There is much more disturbance from bubbles, vegetations, rays from the sun, and so on. To be able to pull this off, we used an enormous amount of training data and custom algorithms. And the system is very capable at only detecting fish, minimizing false detections. This video is from northern Norway, where we have really clear water. Then there's no problem at all detecting the fish. I wanted to highlight the capabilities of the system with an example. And this video is from the Alta River in northern Norway. So as the system is designed, it will create a registration for each fish that passes by the camera. But sometimes there might be fish that you are not so interested to monitor or count. The client at this site was not interested in recordings of small juvenile salmon, which constantly swam in front of the camera, generating hundreds of registrations each day. The solution for this was to use our algorithms for real-time species identification directly on the edge device. With that, the system can simply ignore all non-target fish and only save events involving target species like salmon, pink salmon, and sea trout. Let's jump to our newest product, or rather service. This is the Tiva Edge. It's our answer to a recurring question from customers we get who already invested in camera equipment or have some special use case. The Tiva Edge is a standalone processing unit that receives video stream and then applies our custom detection and tracking algorithms in real time. The results, like fish species, count, directions, are then uploaded into our Tiva platform, just as the data comes from one of our fish counters or underwater cameras. But let me show you some examples. This installation is from a counting window in a fish pass, where they normally they use to manually count the fish. So in the current system, they use motion detection for triggering recordings. The personnel or the local staff then have to manually go through all the videos and manually enter dates, and species, direction, etc. into an Excel spreadsheet. And this is very time consuming. And there is also situations here where multiple fish can stay in the window for long periods, always triggering the motion detection, while another fish swims by at the same time. So you have to look through all of the videos. At this location, we installed our system to get automated counts with tracking of each individual fish and also species detection. All of the data is continuously uploaded to the platform, where staff can view and follow the migration data online. This saves them a lot of time. This is a special use case, but illustrates the capabilities of the edge device in a good way. And this is currently running at an eel passage. So the eels This project is not official yet, so I can't show too many pictures of it. But essentially, the eels climbs up a normal eel pass, and then they pass like a counting box. And when the eel passes the counting box, they climb over a crest, and then they slide really fast down a steep slope. And that is where the camera is placed to detect and count the eels. The eels are passing by at a short distance from the camera at high speed. So the system running the detection and tracking algorithms at 60 frames a second. Still, we're able to count the eels in real time on the device. The small dots that you see in the picture, and you've probably seen them on previous slides on the images to the right, they represent the tracking history of that specific object or fish going through the system. But this strategy, performing the fish detection on the edge, has two big advantages. First, it dramatically minimizes the number of false registration. This, in turn, saves enormous amounts of data storage and, most importantly, countless of hours of manual review time for the user. The counters, cameras, and the Tiva Edge are only one part of our platform. We have also put in a lot of effort to make the system as user-friendly as possible. These edge devices, they can be configured locally, of course. You just connect to the system's Wi-Fi with your phone or a computer, and you can control all the settings. But you can just as easily do this and change the settings from remote through a secure encrypted tunnel to the system using a standard web browser. So you don't have to install any third-party software or something like that on your computer. And with this secure tunnel, you're also able to view the live feeds from the cameras. In the settings, you can also enable continuous recordings of the cameras for validation. Normally, we have the continuous recording at a lower frame rate and a lower resolution to save some space. But the continuous recording is important. Many clients likes to have it because it allows you to validate the system and make sure it works as expected and you don't miss any fish. All collected data from these edge devices continuously upload the data to Tiva's cloud platform. And this is essentially the user's control center. And this is also accessible through a standard web browser with a secure password protected account. And here you can follow the fish migration in near real time through visual dashboards and charts. The platform also includes interpretation interfaces where the user has complete control of the data. Every single AI generated registration from the edge device can be manually reviewed. If the AI has made an error, the user can easily correct and add comments. This ability for manual validation is crucial, ensuring the scientific quality and traceability of data. The interface is also designed with speed in mind. As I told you in the beginning, we've been working with fish counters and fish counting data for a long time, and we've gone through a lot of fish registrations. So this whole interface is built for speed. So you're able, with these responsive interfaces and keyboard shortcuts, to quickly go through a large amount of fish registrations. In the platform, there are also powerful tools for filtering the data, generating reports, exporting data to formats like Excel for further processing and analysis. It is also possible to connect the system to a public platform where everyone can view registrations from the device. And this is actually a pretty big thing in Sweden. On the Swedish platform we have several 100,000 visitors each month during fish migration periods from spring to the autumn. And you can also broadcast live streams from the camera to YouTube, etc., as long as you have a stable internet connection. Let's talk about system uptime. System uptime is absolutely critical for these devices. A system that is down for a week during peak migration can spoil a complete season's worth of data. So built into every unit is continuous health monitoring. If there is a problem, like a power outage, an alarm notification is immediately sent by the system, and this allows for a quick trip to the site to fix the problem, minimizing data loss. And the picture with the beaver is actually not a joke. In Sweden, we have beavers biting through cables on several occasions. And we have also put a great effort into making our system as user-friendly as possible, from the initial installation to ongoing service. The systems are designed to be installed by personnel without any specialized technical skill. Everything is plug and play. You just connect a power source, either from the grid or from solar panels or batteries. Insert a SIM card to the included 4G router or use an existing internet connection. And the system is up and running, starting to count fish, and you can instantly view the results from your computer. Equally important is serviceability. The critical factor here, if something breaks, is to minimize downtime. The system is easy to troubleshoot, and there are very few components involved. Let's take the fish counter, for example. All the sensitive electronics, cameras, computers, sensors, etc., are enclosed in the air-filled camera cone. If one component were to fail, we can quickly send out a replacement cone, and the user can replace it on site, just with 4 nuts and a couple of cable connections. And just a few extras to mention. Our system can be integrated with the PITTAG system. We prefer to use the Oregon system. It has been proven to be very reliable. And I think we have almost 10 installations with integrated PITTAG antennas. We provide a custom antenna that fits to the counter. And the PITTAG reader connects directly to our system. And the data from both systems is accessible on our cloud platform. So it automatically, if a fish is PITTAG and it moves through, it automatically gets associated with that registration and that PITTAG. So it saves some time, this as well. It is also possible to connect different environmental sensors to the system. A temperature sensor is included in both the fish counter and the underwater camera. Also, the system is really power efficient, running at only 25 watts. But this makes it possible to run the system on solar power and batteries for most part of the year. I want to conclude the product section by clearly managing expectations and the limitations of the system. For the fish counter, as I said before, it's important to remember that the design of the installation is critical. It's really important to design the installation in a good way. I want to stress that, so that is perfectly clear. The automatic species recognition, that works best in the counter, where we almost always get a perfect side view image of the fish. Currently, we have about 15 fish species for automatic recognition, and we are continuously adding more. The biggest challenge with the automatic species detection is small cyprinids, especially at night or in turbid water. Even though we have really high quality cameras, a trained fish biologist looking at this video in turbid situation can have a hard time being sure what kind of cyprinid species it is. So the AI will struggle with this as well. And if there are large schools of fish swimming through the system at the same time, there might be occlusions, they are called. That's when one fish is blocking the view for the camera for another fish. And that can happen. So it's always good to practice to manually validate situations like that. The size measurement from the 3D camera is generally accurate, but can be affected. Downstreams migrating eels, for example, can swim coiled up, causing us to measure a shorter length than the actual one. You can adjust for this in the platform. In extreme turbid water with large particles, the 3D camera can also measure the distance to a particle instead of the fish, and this can also cause some deviation. For the TIVA underwater camera, flexibility is the great strength, but it's not an exact counter. It's more like a fish monitoring tool. Fish will be able to swim outside the camera's field of view. Species identification on the underwater camera can also be more difficult, as the fish don't always present a perfect side view to the camera. it won't be as accurate as a fish counter, and it's important to choose the right tool for the right question. So I hope this presentation has given you some insights into TIVA and what we're doing. The company is quite young, but we have a long experience of working with environmental monitoring and fish counters. Some of you might never heard about us before, and the reason for that is probably because we started selling our system outside of Sweden just last year. Before that, we only focused on the Swedish market. So far, we have delivered 120 systems to 11 different countries, and we have local distributors in Great Britain and in Norway. The client base is quite diverse, but the majority of clients consists of hydropower plant companies and authorities alongside research institutions. So thank you for your time. Me and Christian are now happy to answer any questions.